All right, so let's do the last section here, and we'll talk about Serverside Technologies. Now you can request a banner with a GET request or any other HTTP request, and it will tell you some information about the server at the top. Things like what version of Apache it's running and so on. And if you just have a default install of a web server, it will leak a lot of information that you really shouldn't be telling people, like which version of cryptographic libraries you're using. So it's considered a good security practice to modify this stuff so it doesn't give you all that information, but a lot of people don't know that. You can run tools like HTTP Recon is one of the tools that will scan a website and try to determine what version of software is being used, even if that is not just obvious from the banner. It will try to notice subtle cues like minor details in the requests and responses. The way Nmap can fingerprint an operating system, this tool can fingerprint a variety of server-side technologies, like this one finds out which version of Apache it's running and so on. And there's a thing called Wapalizer in your browser. You can add it, and it will do the same thing to a website. So if you run that on my hackathon, it will tell you quite a few of the technologies in use, like the version of PHP and Twitter Bootstrap and so on. So that's handy. And you can tell from the URL. The file extensions tell you about the operating system. Microsoft uses ASP for active server pages. Java uses JSP. PHP is what you'll find on servers running PHP, of course. And then there's other things that are less common, like Cold Fusion or Perl and so on. And you could even see DILs if there's compiled native code, although I've never seen those in a URL. In principle, it could be done. One thing I've seen quite a bit is this sort of thing, where you have an error message. This is the kind of ASP.NET error message you see. Years ago, I used to do a lot of tests of websites, and I tested the Republican National Convention's website, and all you had to do was add a funny character to the URL, and the whole page would be screaming, leaking ASP source code. And I decided to just wander away and not mess with them anymore, because their website was very messed up, and I thought there might be big trouble if I pursued that. So this error message tells you what it is. It implies you can tell what the resource is by recognizing it. If you have a generic error message, this is just a generic error message from your browser saying the page cannot be found. It doesn't really tell you anything about the server. All right, and you can, by the way, adjust in your IIS. You can tell it to have different error messages for different DILs. So you can have different extensions that lead to different error messages. And you can do this on your website too, in a content management platform like GoDaddy. And in fact, this was a vulnerability, I think, in the one I use on 1&1. If you didn't make a custom error page, the default error page had something like cross-site scripting that could be used to do something bad. Anyway, and there's this strange URL structure with commas over here that is OpenText. I think it's a content management platform, and it has this strange URL structure. So you can detect something about what platform is being used by just looking here. You can look for directories too. There's characteristic directories from WordPress. I see this WP login directory and so on. Here you've got Rails for Ruby on Rails and Oracle and Java. That's why you can get used to spotting it. And the cookies are often very obvious, like JSession for Java, ASP session for Microsoft, and Cold Fusion and PHP. So the cookie names, and these are the session tokens too, that are usually identifying who you are, have common, obvious names. So you'll see that in burp in the request. And there's others. Now, when people make a website, they typically don't write the whole thing. They just connect to a library to do all the ordinary stuff like shopping carts, login, message boards, and so on. And whether they use open source or commercial, there's just an endless flood of vulnerabilities and patches. And if they're using an old version of something, you can often find a way in. So here's some recommended steps to hack into a website. First, find all the places where you can put in user input. Look at how the query string is formatted, and find other channels that let people input data, because that's your attack surface. These are all the ways that somebody might send attack code to your server. So you look at the banner to find out what servers are being used, and other software identifiers and HTTP print, this sort of thing. And then once you find what they're using and what versions they're using, you can check with Google and other search engines to find vulnerabilities. Each one has its sites use different tech for handling cookies and Python to server pages. Yes, I think they can. In fact, mine does. I have PHP and I also have Python scripts, and they're connected. Yeah, you can be running different things. They might be on the same server, they might be on different servers, but this is what leads to most of these vulnerabilities, because people will add another function to your website by adding another server or something, and then they'll get it working, but they might not get the user accounts and session control working just right for it. So that's what you typically find. It's often many different technologies working together to make your page, and they don't really completely work together properly. And that's what opens up holes you can use. So HTTP print we talked about. There's other things out there like Nmap and Netcraft and Shodan are websites that record server history and server the setup of servers. So you can use them to find out what was used in the past and now. And so look at the session tokens, and there are many other ways to determine what technologies are in use, from things like cookie names and scripts and so on. And so if after a while of doing this, you get used to the famous stuff like Java, but if you see something you don't know, which certainly happened to me when I was in the DoD program, everything there was on .NET Nuke, and I didn't know much of anything about .NET Nuke, so I learned more since then, but you might have to download the software and run it locally to find out how it works. All right, and anyway, so you can identify server-side functionality here. You can see this thing is got this JSP here that tells you it's running Java server pages. If you look at the parameters, it's got order by name. Now that looks like a SQL query. And if there's something like the order by there, then you might be able to do SQL injection there. Is expired is a parameter here. Is expired equals 0. So that suggests that you might be able to change that and see expired content, which might be interesting. Here's another one. This is running on a Microsoft server running ASPX. You can see it from the file extension. It's got an edit equals false option. So changing edit to true might do something. This template is pointing to a file name, newbranch.tpl, so that might be vulnerable to path traversal. You might be able to put .. and point to some other file here. And there's a version parameter, so changing that might show other versions of stuff. Those are all areas to investigate. And here's a PHP file, and it's posting what looks like an email here. Obviously connecting to an email server with these from, to, and subject lines. And so you might be able to use this to send emails through their email server. I've seen that before, and that would be interesting. And you might be able to inject email headers. If you can send carriage return line feed, you can insert a whole email in any one of these fields. So, it's that would be the way to try to exploit that. Here you've got a thing that doesn't have any complete file names. It's just got a bunch of little areas here. So this is probably EIS and then some kind of manager file, which then has parameters, schema equals pub, type equals media, and so on. So this is an action. So this is another one of these funny RESTful type parameters, where these are parameters, and it looks like even the name of the application is some kind of default value that's not explicitly here. if you find that some part of the application is always the same, like one thing I mentioned before is you might have a random number generator, and the random numbers that are generated in various parts of the application all look the same. And there was an app I was looking at yesterday, Find My Boat Android app a student asked about, and it had a parameter to identify you, and if you log out and log in again, that parameter remains the same. So that's interesting. That means it's using the same module to make it. And so you might find code reuse on a page, and so you might be able to find there might be filtering code that's used everywhere, authentication code that's used everywhere, and so on. And so you might be able to investigate it. There have been vulnerabilities where you were able to find another part of the page that would expose a random number, which was supposed to be a secret on some other part of the page, but it was using the same random number generator, that sort of thing. If it obfuscates data, try to find some place where you can see the obfuscated string and the original. It might be using the same form of obfuscation everywhere. I've done this one, systematically varying values. There was a Stitcher, the podcast music streaming app. I don't know if it does podcast, I think it does music. They were using the Caesar cipher for passwords. So I just tried a password of A, B, C, and I could see it counting up through the letters. A lot of errors. Have you seen if they don't handle errors correctly, you'll see an error page that tells you too much information, even showing you lines of source code. And there are Google Dorks to find vulnerable pages once you've found things. Like here's something about illegal things in Microsoft Net. Here's a PHP error log visible to the world. This is a Microsoft product. Elma is a fairly common log viewer. I had fun with this. I learned about it from Troy Hunt years ago. I found, I think, OpenToyota one and other ones where you can see the error logs on their server and you can trick it into exposing other people's cookies. So there's just, these things are called Google Dorks, these particular Google searches that will find pages that are vulnerable. And that's what a lot of script kiddies use to like deface a lot of pages. You find how to do one exploit and then you find all the pages with that vulnerability and exploit them. And here's an example. I went to Walmart, did this, I think, a couple of years ago, and I just put an apostrophe or a quote at the end of the line, and this is what happens. It freaks out and gives me one of these overly verbose error messages, so now I know they're using Microsoft.NET, and I know what version, and what version of ASP, and so on. You know, this is the kind of thing you should not be showing the customer. They ought to see some kind of controlled, pretty error page that does not reveal any internal information like that. All right, so look for a consistent framework and the parts that are bolted on later. Debugging functions, logging functions, CAPTCHAs, these might be not integrated properly. You can notice parts of the page that are newer, that look different, that were obviously written at a different time or left over from an earlier time. So look for client-side validation, things that are checked on the client side instead of on the server side. Look for how the database is used. Watch for areas where you can upload or download a file. This is typically how you hack WordPress and PHP-oriented sites, because a large number of PHP-oriented sites have some way you can post something, like a comment or an image, and you can very often trick it into interpreting that uploaded thing as a script and running it. That's the most common way to hack into PHP sites. All right, and if there's any data that came from the user that is then displayed somewhere, then you're likely to have cross-site scripting if they don't filter the tags out of it. And if they redirect from one page to another, you might be able to trick it into redirecting to a different page. So social networking features might have stored cross-site scripting, like the famous MySpace attack, where you can put script in a comment on a social network, which is then everybody that views it runs that script. For logins, you can find weak passwords, flaws in logic, predictable tokens in a session state, so you can find out other people's tokens to get in. And so horizontal privilege escalation is moving over to another user's account. Vertical privilege escalation is moving to a higher level of privilege, like up to administrator. Impersonating people is another way to do it. And they might be using clear text communications, so you can steal credentials by kicking up the traffic, by sitting near somebody in a wireless coffee house or something, back in the days when we could sit near people. Sometimes information leaks in the referrer header or to external systems. That's useful. Error messages, as we've seen, can leak out unnecessary information and possibly useful information. And third-party components with known vulnerabilities is one of the OWASP top 10 application vulnerabilities. This is why people are now increasingly selling products that will just list all the technology you're using and tell you if it's all patched. That turns out to be a whole lot harder than you might think it would be. And this is why one simple answer that a lot of companies do is they just force you to use the Microsoft version of everything, because then you can use one Microsoft tool to update it all and know it's all updated. But if you use stuff from everywhere, then there is no simple tool or simple list that will tell you if it's all updated. All right, and so here's some examples, and I think this is from my Hackathon server, but anyway, here's places you might go. It might be from the book. Anyway, auth contains authentication functions like login and reset password, so you might have access control there. Core site stats is here. This is recording some kind of record of what you've been doing, so you might find parameters in there or leaked out information. Home is here, and that should be authenticated content, so you can see if there's some way to move over and see somebody else's home directory. Icons and images is static content probably. You're probably not going to be able to do much of anything there. It's just going to be a directory of static files. Pub has got a series of RESTful resources here. Yeah, there's a numerical value, so you can try just changing it to other numerical values and see what you can see. Looking for insecure direct object access, where something with a different number is visible that really should only be visible if you have authenticated as a different user. And shop is here, having a lot of different items all handled similarly, so you can see if there's some way to exploit that. You know, this is just, you can spend a lot of time hunting for things, but it's usually not that frustrating, I've found. I know I do it for Android apps. People are asking me how I found all these Android apps. If you just start testing Android apps, you find things, even if you only know a couple of simple tests. It's not like you look through 200 things, you don't find anything, and you feel like you're wasting your time. If you just try 10 or 15 apps, you'll find some simple problems, and that encourages you to keep going. And web apps, I think, are similar, a high vulnerability of problems. Anyway, this is the last Kahoot, D, which is here. Oh, I wanted to. Make my glorious soda water. Looks like 8. Okay. Not quite. Oh, good. I'm glad I waited a few seconds. All right. I guess we got everybody now. All right. What browser extension will identify the web server technology? All right, Wapalizer. Pretty silly name, but that's what it is. What file extension is on a LAMP server? All right, and so PHP, of course, because that's Linux, Apache, MySQL, and PHP. All right, what directory name would you find on an Oracle server? Okay, that's PLS. I can do it by process of elimination. Servlet is Java. This is Ruby on Rails, and that's Cold Fusion. All right, what token name indicates a Microsoft server? Yep, there it is, ASP, Microsoft's active server pages. All right. All right. All right. I'm going to save that. Okay. So, that's it for the lecture. Let me stop this recording.